Hello, YouTube. This is Mr. Bakari, and today we are going to graph a hyperbola. Okay, so first, I just want to show you an image of a hyperbola here, and all the major important parts of it are labeled for us. And so we need to make sure we understand this vocabulary here. So this is a horizontal hyperbola. And we know that because the branches of the graph open left and right. Okay, if we rotate this 90 degrees, this is what a vertical hyperbola would look like. And now you can see the branches open up and down. Okay, so whatever axis your graph lies on, that is called the transverse axis. Okay, and that is the axis that will have your focus or foci. The other axis is called the conjugate axis. That is the axis that you do not graph on, and you will find the co-vertices on it. And this little box in blue here is just an outline that extends from all the vertices. So you draw a box around the vertices, and from each corner diagonal, you extend the asymptotes of the graph. And so the box is basically just a guideline. All right. Now, if we look at the equations here on the left, the top one is a horizontal hyperbola. And the way we know that is because the first term or the positive term is x. So that would be a horizontal hyperbola like you see here in the picture. The bottom equation is a vertical hyperbola, and we know that because the first term or the positive term is y. Okay? A squared is always under the first or the positive term, and b squared is under the negative term. All right, so let's go ahead and graph one. Okay, so if we look at this equation here, you will see that the first term is x. So our positive term, our first term is x. This is a horizontal hyperbola. Okay? And the first thing we will do is we will write the center. And that is HK, which you will find up in the numerator. So the center of this hyperbola is at 1, negative 2. Okay, we can go over here and graph it. 1, negative 2. All right. Now, since this is a horizontal hyperbola, we're going to look at the denominator of our first term, and that is going to be a squared. So if we take the square root of that, we have a, and 2a is going to be the length of our transverse axis. So I'll split that, and I will go 1, 2 to the left, 1, 2 to the right of center, and that is our transverse axis. These are our vertices. Okay? The 9 is our b squared. So if we take the square root of that, we get 3, and 2b is the length of our conjugate axis. So we split 1, 2, 3 up and 1, 2, 3 down. That is our conjugate axis, and those are our co-vertices. Okay? Next, what I want to do is I'm going to draw a box connecting the vertices. So you're going to draw a rectangular box around the vertices just like this. And this basically is a guideline because the asymptotes of our hyperbola will extend across the diagonals. Okay? So I'll go ahead and graph that next. So I'll extend from the top left to the bottom right, and from the top right to the bottom left. And there is our asymptotes of our graph. Okay, and they go right through the center. Now we can graph the hyperbola. Remember, this is a horizontal hyperbola, and I have drawn these previously just to make sure they're neat, and they will be drawn just like that. Now notice they extend for the vertices, and the ends of the branches of the graph head towards the asymptote. So you don't want to draw a parabola here. You want to make sure that the branches are heading along the asymptotes. Okay, so now let's label the vertices. You might be asked to do this. We're just going to go around and we'll label the major vertices first. So this is at -1, -2. And the other major vertice is at 3, -2. Okay. If you're asked to label the co-vertices, that will be the vertices on the conjugate axis. So this is at 1, 1, and at 1, 1, 2, 3, 4, -5. All right, so those are our vertices. The foci. Now, every conic has a focal equation. So for a hyperbola, it is Pythagorean theorem. So it's going to be a squared plus b squared equals c squared. So remember, our denominators are a squared and b squared. So basically what this says is 4 plus 9 equals c squared, which is 13, which means if we take the square root of that, then c is the square root of 13. Okay, c is the distance from our center to the focal points, the foci. Now, the foci are always graphed along the transverse axis. So I am going to go left square root of 13. So that's between 3 and 4. So I'm just going to go 1, 2, 3.5. And go back to center. 1, 2, 3.5 to the right. And there are my foci. Okay. Now I need to list them over here. So the way we do that is basically if it's a horizontal hyperbola, it's going to be h plus or minus c comma k. Okay. If it's a vertical hyperbola, it's going to be h comma k plus or minus c. All right. Now remember, c is right here. That's the distance from center to the focus. All right, so this is a horizontal. So I'm going to go to the origin. I can go right 1 plus or minus c root 13, comma, go down 2. Okay, and those are where you'll find the foci. All right. Now, E stands for eccentricity. This is a value that is assigned to a conic that describes how circular it is. Okay, the greater the number, the less circular it is. To find this, you take c divided by a. Okay, so c is root 13. And remember, this is a squared under the first term. So take the square root of that, and that is our eccentricity. That number should always be improper. It should be greater than 1. Okay, trans just stands for the transverse axis, and that is asking us the length. So that's vertice to vertice, which would be 4. Conjugate axis, vertice to vertice, that will be 6. Okay? And lastly, we are going to write the equation of the asymptotes. So these are typically written in point slope form. So point slope form is y minus k, and k is -2, so that would be a +2, equals plus or minus the slope. And as you can see here, the slope is 3/2. Rise, run. Got a positive and a negative. So that is 3/2 times x minus h, and h is 1. So x minus 1. Okay? All right, so if you've got a graph, you can just look up here for the slope, but you might want to note that for a horizontal hyperbola, the slope is going to be b over a. So remember, this is b squared. This is a squared up in the equation. Take the square roots of those. B over a, and you'll get the slope. If it's a vertical hyperbola, that's going to be a over b for your slope. Okay? And that is it. There's your hyperbola. I hope this helps you out, and I will see you in the next video.